This is Mrs. Naslin, and today we're doing Unit 2, Lesson 1, Congruence, Similarity, and Symmetry. Our learning targets for today are, I can identify congruent figures, I can determine similarity, and I can explore lines of symmetry and congruence. The vocab we'll be talking about are plane, congruent, congruence, similar, line symmetry, line of symmetry, reflection, and line of reflection. All right, so the first two vocab words that are really important to understand are congruent and similar. Shapes that are congruent are shapes that are the same size and shape, even if they are turned a different way. So we have two different shapes, same size, same shape. So for example, if I were going to draw two congruent figures, I might draw this little box, and then I have to draw one exactly the same size, same shape. Hopefully I'm pretty good there. Okay. And then I would say that they're congruent, and that one's even a little small, but it's close. Similar figures are figures that are the same shape but are not necessarily the same size. So for example, if I do one circle and then I do a bigger circle like that, these two shapes are similar. They're the same shape, but they are not the same size, versus these two are. And actually I'm going to even make it a little bit better. Here, I'm going to delete this one. I'll just copy this one. There we go. Now they're exactly congruent. Same shape, same size. Okay? All right, now they could be rotated. Even if I rotated this one a little bit off, as long as they're the same shape, same size, it doesn't matter. They're still congruent. All right, let's practice that. So I want you to look at all these and say, yes, they're congruent, or no, they are not. So we're only looking at congruency. Again, same size, same shape. They could be rotated. They have to be the same size, same shape. So is this one congruent? And the answer should be, yes, it is congruent. Okay, they're the same size, same shape. All right, how about this next example? There we go, got rid of it. Let's look at this next one. Are these congruent? Same size, same shape? And the answer would be no, they are not congruent. They are not the same size, same shape. Okay, they're different sizes. All right, how about this one? Go ahead and try this one on your own. Are these two congruent? Say yes or no. If you said yes, they are congruent, then you were right on, okay? Because they are congruent, they just change the way they look, right? This one just turned on its side, but it is the same size, same shape. How about this one? Are these ones congruent? Yes or no? If you said yes, you are right on. They're the same size, same shape. Oops, I'm drawing all sorts of things here. Same size, same shape, they've just been rotated a different direction. Okay. All right. Let's look at the next one here. We'll do one more. How about our number 9? Are these ones congruent? If you said no, you're right, because they're different sizes. They're getting progressively smaller. They might be the same shape, but they're different sizes. All right, let's continue here. All right, next we're going to discuss similar figures. So again, figures that are the same shape but are not necessarily the same size are similar. So if we look at these two shapes here, these figures are similar. They're the same shape, but they are not the same size. And a way I like to think about it, pretend you're on your iPad and you can do the pinch and grow. If you could pinch and grow the shape and get it to fit exactly on the bigger shape, then you know that they are similar. These two are not similar because they are not the same shape. If I did the pinch and grow on this square, it would get a lot bigger than this shape here, because right now it's already taken up 2, and if I was to grow it bigger, it would get bigger and bigger in all directions, and it would be way bigger than the rectangle there. Now, congruent figures are exactly the same size and same shape. Okay, we talked about that earlier. the figures at the right are congruent, right? These are congruent, same size, same shape. But we also say that congruent figures are also similar, okay? So even if the shape is congruent, they're the same size, same shape, they're also similar because they're the same shape, okay? So that's kind of a little confusing. Congruent figures are also similar, but not all similar shapes are congruent. So let's go ahead and look at a couple of examples here. It says the side of each pair of figure appears to be similar, right? Similar or not similar. So again, similar are the same shape but different sizes. So go ahead and decide for number 12 there if you think this shape is similar or not similar. If you said, oh, because that's not going to write, if you said, oh, it doesn't have anything. If you said similar, you were right. We'll just say it that way. How about number 13? Are these similar or not similar? If you said not similar, you were right. Pretend you took and you expanded the smaller one. So if I did the little pinch and grasp or pinch and expand like you would on the iPad, right away you would realize that it is not going to be the same as this bigger shape. So these two are not similar. All right, let's keep going. All right, next we're going to try to do a couple of these ones. It says write true or false for each sentence. It says draw an example. So are all squares are similar, true or false? Well, let's go ahead and try it and see if we think that is true. So I'm going to go ahead and draw a square here. There's one square, and I'm going to draw another square. All right, so what do we think? Do all squares, are they similar, true or false? The answer is true. All squares are similar to each other because if you think about it, if I took any square, I would be able to expand it to fit into any other square. So they are similar. How about this one? Are all right triangles are similar? I'm going to draw a couple of examples and we'll talk about it. All right, so you'll see I have two right triangles here. One's a little bigger and one's really, really small. So are they similar? Okay, remember same shape but different size. And the answer is no, these are not similar because I can shrink it down a lot bigger or expand one of my lines and it really changes the shape of it. So the answer is no, right triangles are not always similar, or false. They are not always similar. All right, let's continue. All right, now we're going to talk about how to identify lines of symmetry. So it says a plane figure has line of symmetry if you can fold it to make two parts that are mirror images. The fold is called a line of symmetry. So basically, if you could take the figure that you're looking at and fold it in half and it would be exactly the same on both sides, then it has a line of symmetry. So let's go ahead and take a look at a couple of examples here. Let's look at this little oval here. It says, first off, does this have lines of symmetry, yes or no? And I like to actually draw the lines. It helps me see them. So I'm going to draw a line here, right down the middle if it works for me. All right. And you can see that if I folded right on that line, this side would fit exactly on this side. I could also go this direction and fold it right on the line. And I could go, this side would fit exactly on this side. So yes, this first one does have a line of symmetry. How about, I don't know if it's going to let me move it. Okay, there we go. How about this one? Let's go ahead and try drawing our lines. I could put a line here. Maybe if I get my mouse to move. There we go. And I could fold these two, would be exactly the same. And I could put a line here. And these two would be exactly the same. So yes, this one also has a line of symmetry. All right, how about this shape here? Could we make this have a line of symmetry? What do you think, yes or no? All right, let's see. I could draw a line right down the middle, and that wasn't quite in the middle. But if that was right in the middle, maybe I can even move it over. If that was right in the middle, then yes, I could form a line of symmetry. And I can't quite get it over, but if it was right in the middle, yes, this side would be the same as this side. All right. How about this one? Would I be able to form a line of symmetry for number 22? Go ahead and try that. If you said yes, you're right on, because I could do one here, and I could do one right through here. How about number 23? Could I do a line of symmetry? Yes or no? If you said no, you were right on. There's not a good way to do it. If I would try to draw a line like this, I can't make those two be equal. And if I tried to draw a line this direction, I can't find a way to make those two equal either. So there is not a good way to make a line of symmetry for number 22. All right. And this last one, let's go ahead and draw the line of symmetry for that. And you should see that yes, there is a line of symmetry on this rectangle as well. All right, so now it's going to ask us which figures have more than one line of symmetry. So which ones were I able to draw lines of symmetry in multiple directions? So let's see, we could do it for 19, 20, couldn't do it for 21, 22, and 24 were the ones that we were able to draw the line of symmetry for. All right, move that out of the way. Awesome. All right, and last thing I wanted to show you were these last two examples. It says draw the other half of each figure to make a whole figure with a line of symmetry. So what they did is they drew one half of the figure, and you're supposed to draw the other half of the figure. And I just wanted to show you a technique for this. They've already been drawn for us, but what I always do is I look and I say, okay, it goes over 1, so I'm going to draw it over 1. Then I notice that it goes diagonal up 1, so I go diagonal up 1. Then I notice it goes up 1, 2. So I'm going to go up 1, 2. Then I notice it does 1 diagonal. So I go 1 diagonal, and then I go over. So I basically keep looking back at the image above it to make sure I jot exactly the same. And that kind of helps. Or I can look at this like in the middle point here. I can say, oh, okay, this one is 1, 2 up. So this is going to be 1, 2 down. So you can kind of use that to help you gauge when you're trying to draw the other half of a figure that has a line of symmetry. All right, so today we talked about a lot of different things. We talked about congruent shapes, we talked about similar shapes, we talked about the line of symmetry. Great work.